Q&A.
Hello, everybody, and welcome to the Great Storage Debate, where we're going to debate hyperconverged, disaggregated, and centralized storage options. So, without further ado, let's get into who will be our debaters. So, I'm your host, David McIntyre from Samsung, and I'll be refereeing our five distinguished panelists. Walt O'Brien from Dell Technologies, John Kim from NVIDIA and also SNIA chair, and Christine McMonagle from Intel. And let me tell you a little bit more about each one of them. So Walt is a Dell Fellow in the Infrastructure Solutions Group of the Office of the CTO with over 20 years experience delivering enterprise storage products. John Kim, he will be focusing on disaggregated storage. John is Director of Storage Marketing at NVIDIA in the Networking Business Unit, and he's chair of the SNIA Networking Storage Forum. He previously worked at NetApp, EMC, and Mellanox. And last but not least is Christine McMonagle. She will be focusing on hyperconverged storage. Christine directs hyperconverged strategy and partner engagements for Intel's Data Platforms Group. She has over 20 years of experience in the computing industry across products and services for networking and communications, PCs, handheld storage systems, and hybrid cloud solutions. Ladies and gentlemen, these are your contenders. So here we are getting into what is SNIA at a glance. Well, SNIA has 180 industry-leading organizations participating within our fine organization. 25 active contributing members, and supports 50,000 IT end users and storage pros worldwide. So learn more at snia.org/technical. And the technologies that we cover here at SNIA include Ethernet, Fiber Channel, InfiniBand, all the networking alphabet soup and buzzwords that you want to learn more about. We talk about virtualization, hyperconverged infrastructure. Like today, we're going to learn something about that. SDN, storage protocols, block, file, object, and securing data. Security is an important one these days. So you're going to learn a lot on this call. And all I ask is that any slide or slides used must be reproduced in their entirety without modification. The SNIA must be acknowledged as the source of any material used in the body of any document containing material from these presentations. All right, ladies and gentlemen, these are your ground rules. No hitting below the belt. Be fair and square, but get your points across, and be prepared for some really compelling questions during the great debate, which is the main event. We will go into centralized storage, disaggregated storage, and hyperconverged infrastructure. And then we will have a cool down session because it's going to be a really exciting debate. And so let me give you just some quick definitions to calibrate our audience. So centralized storage, what is centralized storage? Well, SNAP definition says it is the storage of files, data, and databases shared between computing servers over a network. It is also known as network storage. SAN, NAS are examples and are different from storage that are stored data storage locally or direct attached storage. Disaggregated storage is a type of data storage within data centers. It allows compute resources within a computer server to be separated from storage resources without modifying any physical connections. And then hyperconverged infrastructure, well, that is a term which refers to when storage is bundled with compute and networking in a single virtualized cluster. Defined software management policies are there for to manage flexible storage pools and replace dedicated hardware. And with that, we're going to get into our first contender, which is Walt O'Brien, who will make the key points on centralized storage and then pass it off to his follow-on contenders. Walt?
Got it.
I'm Walt O'Brien. I'm from Dell Technologies, and I'm going to sort of just introduce centralized storage. You probably know it well already. Comparing it to local storage, when we first introduced storage area networks, one of the key problems we were trying to address was stranded storage. And centralized storage did that by sort of moving the drives out of the servers into centralized storage, and then allowing us to do sub-allocations, not just whole drives, but parts of drives, and then share storage. The protocol support, when we first did storage area networks, obviously that was blocked, but it also includes iSCSI and NVMe over Fabric and NFS and SMB for file protocols and object protocols as well. It's sort of agnostic. It's that centralized storage separate from servers. So it got some advantages with it. One of the things that it enabled was it enabled server failover clusters. You could do that before. For example, when you were directly attaching to SCSI storage arrays, for example, you could do failover clusters, but you had a limit in the number of devices, the number of systems that were able to attach. Centralized storage, which is networked, enabled that to be used much more broadly, where you could have your database running on one server with the storage for that database stored in the central storage system. And if that server went down, another server could pick up for it, accessing the same database and continuing operation. It also enabled golden images. That sort of shared storage capability lets you create a golden image, for example, for a disk image, and bring up a new server quickly, leveraging those golden images. And it enabled the compute and storage to scale independently. You could add more servers, or you could add more storage into your environment. It also brought a whole bunch of advanced capabilities. One of the big ones was centralized management. Instead of managing a whole bunch of servers individually, you could manage from a central place your storage resource. It also enabled shared data services that could be shared by all of the servers who were leveraging that shared storage. High availability was, one of the big ones, but also caching and tiering and quality of service management, thin provisioning, compression, deduplication, snapshots. One of the newer capabilities that are being advertised now is ransomware protection to deal with ransomware. So a lot of advanced capabilities shared across all the servers that use that centralized storage. Now you could build your central storage using servers. You could take servers, you could put on front-end cards, back-end cards, compression offloads, drive shelves, all the stuff necessary to build a highly available storage solution, central storage solution. And this is what many more people have done in the past, is you could purchase a storage appliance. That's the traditional storage array, right? That you could purchase from one of many vendors. It was optimized components for storage, no single point of failure design, fully integrated and tested. All the components were tested together, easy installation, easy online software upgrade. If you did it yourself, well, now you need to separately upgrade the OS and the clustering software and the drivers and the storage software, whereas all of that is integrated into an easy online upgrade for typical storage appliance, as well as online repair. Now I've shown here, one little box, but that could be a whole rack or even multiple racks that represent that centralized storage. If you're using a scale-up system with many drive shelves or a scale-out system with many controllers. So, you know, it's sort of a broad set of stuff, but this gives you a feel for centralized storage. John?
Hi, thank you, Walt. So I'd like to talk about disaggregated storage. Let's go ahead and jump into this topic before we have the great debate section. So first, to define disaggregate, that means to separate a collection into, or mass, into its component parts. So in theory, when you come to data centers and servers, you could disaggregate or separate the compute, the memory, the storage, the security, the remote management, etc. But the most commonly disaggregated part, if you're going to disaggregate something, is in fact the storage. And that's because the storage is often something where you need different amounts at different times, and where you can get a reasonable performance by connecting the storage, separating the storage and connecting it over the network. Where, for example, today, most of the time memory, if you connect it over the network, adds too much latency. And so usually they disaggregate, if they disaggregate anything, it's usually the compute and the storage. So an important part, as I mentioned, is the network is there, and faster networking is something that helps enable or drive this disaggregation, because if the networking doesn't have enough bandwidth, or if the latency is too high, then the disaggregated storage will be slow, or you won't get the full performance advantage of that storage. So we see here in the diagram on the left side, we have a typical complex server has all the parts, and the disaggregated stack, we separate the compute, the storage, and perhaps the management and security and other components. So what if we compare local storage to disaggregated storage? And this comparison has many similarities to the comparison that Walt did for local storage versus centralized storage. Because in fact, centralized storage or network storage like SAN or NAS could be seen as a specialized type of disaggregated storage. So typically with local storage, it's fast and high performance. It's easy to set up at the server level or for each server. It's fairly low cost to buy and acquire. But on the other hand, it's usually inflexible, inefficient, and that you never have the right amount of storage. You always have either too much or too little on each server. It's difficult to share, and it's hard to manage in aggregate. When you have hundreds or thousands of servers, then managing the storage on each server becomes a big pain. With disaggregated storage, it's more flexible, more efficient, easier to share, easier to manage in total across many servers, and it probably offers higher bandwidth. On the other hand, it's more complex to set up overall, and especially on each individual server, there's often additional software or hardware or networking required to set it up. And there might be more latency, again, depending on the network setup. And in some cases, it might be more expensive because you need this storage appliances, and you may need additional networking capabilities. So when you look at this, differentiating disaggregated storage, okay, part of what we look at is how is it connected to the servers, and then where does the file system live, or and where does the storage control layer or the control plane of that storage live? Because typically, if you look at centralized storage, as Walt talked about, that centralized storage smarts, which might include the file system, usually lives on the storage array. And with disaggregated storage, while in theory it could live anywhere, usually some part, at least some or all of the storage smarts or storage intelligence lives on the individual servers which are connecting to the storage. So key questions to ask looking at disaggregated storage is it more efficient? Is it more complex? And does it add latency to the storage if latency matters? All right. So that's the end of my presentation on disaggregated storage. Let's go to Christine to learn about hyperconverged infrastructure.
Thanks, John. I will talk about hyperconverged and introduce this topic. Hyperconverged infrastructure is distinguished from these others in that the compute and the storage resources are running together on each server. And then these servers get clustered together across a standard Ethernet network into this sort of virtualized pool of compute and storage resources, with the data distributed across the nodes in the cluster to increase durability. Each time you want to scale, you just add another server. At that point, you're adding more performance as well as more capacity in an incremental modular fashion. You can start small with these, typically around 3 or 4 nodes, and then scale and invest incrementally as you need to grow. At this point, Hyperconverged has really proven itself as a flexible architecture that can support a lot of different workloads and applications in a data center. But the reason that it's become so popular is that it can be very easily deployed and managed with virtual machines. So anyone that's familiar with deploying or managing a VM can deploy and manage the storage with that VM and manage them together. So it's a very familiar model for a lot of IT folks, doesn't require any specialized skill set like some of the traditional storage systems did. And people are typically using hyperconverged as a way to modernize their on-premise infrastructure as part of a larger hybrid cloud deployment with certain resources on-premise and then being able to move other resources out to a public cloud, whatever meets a business's needs effectively. This is a results of a survey from Technology Business Research. They survey businesses using HCI twice a year. And in their latest published survey, which was published in January, they found that 50% of the enterprises surveyed had already adopted hyperconverged. That's up from about 39% the year prior. So pretty big jump. And then another 29% plan to adopt in the next year. And the reason that people are adopting HCI is a lot of the attributes that we talked about on the previous slide. They're looking to modernize their infrastructure. They're looking to overcome challenges with deployment and management of VMs and storage. Maybe they lack IT resources and don't want to need a specialized team with expertise in a certain storage system. So all of that's kind of playing out in these survey results. And then here's some of the latest trends in hyperconverged. There's a lot of focus these days on making edge deployments easier to manage. Hyperconverged has been popular at remote offices, retail locations, bank branches, all kinds of edge sites for years. But there's been a lot of emphasis lately on making those even easier to deploy and manage from a central location. So automating deployments, minimizing the initial node requirement to maybe 2 nodes, sometimes with a remote witness node that's located in a central data center or in a cloud location. And then being able to use a single pane of glass to manage these hyperconverged remote locations from one central site, as well as making those edge solutions more capable of running a certain amount of analytics locally before they transfer the data, the results of that analysis back to a central data center or cloud. While all of the hyperconverged solutions are virtualized, most also support containers now via CSI plugins. Typically, it's containers within a VM, but I'm also seeing emerging use of native container storage as well in hyperconverged. Independent scaling of compute and storage is really kind of central to the debate that we're having today. As originally defined, most hyperconverged solutions had to have each node in the cluster identical or nearly identical. And so as people started to see success with whatever their initial deployments were, start adding more workloads, start scaling their clusters, a lot of times they would find they had an imbalance of compute or capacity in their cluster. And so HCI vendors are trying to find ways to address this now by allowing more mixing and matching of node types, being able to add in storage heavy nodes or compute only nodes to balance those excess resources in the cluster. And this is kind of driving a renewed interest in a certain amount of disaggregation within HCI, while still retaining the ease of deployment and management that people really like about HCI. And then there's a lot of consumption models. Paying for HCI as a service is becoming more and more popular as sort of a subscription, and also more complete hybrid cloud integration from the HCI providers, both public cloud providers coming on-premise with HCI solutions, and then the on-premise HCI providers strengthening their relationships, their capabilities, their network connections with public cloud instances in order to make workload placement more seamless. All right, back to you, David, for the debate.
Okay, great. Well, thank you. Great presentations to the three of you. And let's share some warm-up questions get us started here. So we'll start with Christine. So Christine, tell us, where is hyperconverged infrastructure being deployed these days?
Yeah, I mean, there's a lot of use in a centralized data center as people are trying to find ways to modernize that central data center to make it more cloud-like. And then, as I mentioned earlier, a lot of use in remote locations, edge sites. And then there is some use as well in, I would say, sort of tier 2, tier 3 public cloud providers as well. You know, the super large hyperscalers are really doing everything disaggregated. But when you get down a tier or two on cloud providers, there's definitely use of HCI there too.
Excellent. Thank you for that answer. And so how about Walt? So Walt, why do some customers prefer centralized storage appliances?
Well, the centralized storage appliance have some of that ease of use, both ease of deployment, ease of upgrade, ease of scale. It provides a one throat to choke for the customer when they say, I've got a problem, they've got one place to go for their storage. And it's really the gold standard for storage systems. If you were to look at your bank accounts and ask, where's that data stored? Most commonly you'd find today that's stored on those storage appliances or storage arrays, because those have 5 and 6 nines availability, as well as well-honed remote replication for disaster recovery, et cetera.
All right. Well, thanks for that answer, Walt. And John, so what is the difference between disaggregated storage and centralized storage or a storage area network?
So first of all, on the surface or at a high level, they're really the same. Or we could say that centralized storage is a subset is a type of, or very common, maybe one of the more popular types of disaggregated storage. But in terms of when people say disaggregated storage, they usually mean large-scale storage where some or all of the storage software is running on the servers that talk to the storage, where with centralized storage or SAN or NAS, storage area network, usually most or all of the software is running the storage software is running on the storage array itself. A couple other differences: disaggregated storage, while it in theory can use any type of network, it usually uses Ethernet, where centralized storage could use Ethernet, but often uses fiber channel, or could use InfiniBand, but usually often uses fiber channel. Also, disaggregated storage is usually deployed in some sort of cloud context: private cloud, public cloud, hybrid cloud. It's usually deployed when you have a lot of servers and a lot of storage. Maybe as a rule of thumb, I would expect you probably wouldn't look at centralized storage unless you have at least hundreds of servers and maybe dozens of storage nodes. Sorry, disaggregated storage is usually where you'd see this type of thing deployed. So if you had a data center where you had just 50 servers and 2 storage arrays, it's pretty unusual or unlikely that anyone would want to look at disaggregated storage for that data center or that particular deployment.
Okay, excellent answer, John. And I will tell you, the phone lines are lighting up. So first question from our audience. And this is where I've thrown you folks softball questions. So you probably feel all comfortable. Well, now it's time to get into it. So the debate starts now. What is the performance gap between best of breed storage versus hyperconverged infrastructure? So there it is. This is from the audience. You can't critique me for it. So let's have at it. What is the performance gap between best of breed storage versus HCI?
Well, even though HCI is really about the software capability, it's certainly not independent of the underlying hardware. And the same could be said of disaggregated as well. It all depends on what hardware you have underlying that software. So, if you're going to look at some disaggregated storage systems, right? Some of them are designed to be backup recovery S3 compliant, and they're really not about performance. There's no reason you can't design a disaggregated storage solution that is high performant. And the same could be said of HCI as well. I mean, if you buy one that's a hybrid solution with a lot of hard disks and a low-end processor, it's going to be lower performance. If you buy one that has, high-speed networking capability, highly capable processor, SSDs, things like Optane, persistent memory, or SSDs, then clearly you're going to get much higher performance out of something like that. So it's all in paying attention to that underlying hardware, whether it's on-premise in the system you're buying or out in the cloud from a cloud provider as well.
Real good. Anybody, Walt, John, you want to chime in on that, or?
I'd say, as generally speaking, as a rule of thumb, the centralized storage is usually focused on high performance. It usually has dedicated high performance network connections between the servers and the storage. And then disaggregated storage might have high performance or might have medium performance. People usually wouldn't bother setting it up if it has slow performance, unless it's maybe for cloud object storage. But the performance can depend on the type of storage and the type of network and the needs of the application. Whereas I would say, generally, as a rule of thumb, anyone setting up centralized storage is going to make sure that it has high performance, or they wouldn't bother doing it. And as Christine said, hyperconverged storage could be high performance or medium performance, depending on the way it's set up and the hardware used.
Okay, now, John, you're not on my question list, are you? Because I was going to ask next, what are the key workloads or use cases for disaggregated storage?
Disaggregated storage, the most common workloads are distributed applications. This could be like a NoSQL database. It could be web servers, high performance computing, artificial intelligence, data mining. Often, and because it's typically used for a cloud deployment, it's often for web-based applications or web scale applications. Those are more common. There's no rule that says that disaggregated storage is not by rule limited to any one specific workload or application, but it tends to be deployed with these distributed or web scale or cloud-based applications. Usually not for something like a typical Oracle server or SAP or Exchange or VMware. Those are usually not deployed on disaggregated storage.
All right. Hey, Walt, I would have a lead question for you. How will emerging composable or disaggregated infrastructure change the storage landscape, in your expert opinion?
Well, I think that's an exciting topic, and it's one of the ones that was asked in the chat here. The composable and disaggregated notion is typically around running some extra hardware on the server that offloads some of the work that would have been done for storage on the server to the offload engine. It was originally SmartNICs, and they've started changing the name of SmartNICs to let's see, data compute units. I think that's what they're calling them now.
There's a few different names. Mm-hmm.
Yeah, data processing units. They're really trying to expand the role of SmartNICs that was originally for offloading networking, for offloading storage. And one of the big things that it does, and John and Christine both talked about it, is when you run storage on the server, that means you need to load drivers on the server, and you need to maintain those drivers and that software there. If you offload it to the SmartNIC, the server OS doesn't need to be touched. And customers like that separation of my OS is mine to control and you control the storage part of it. That separation is one of the things people like, as well as using heterogeneous offload, whether it's compression engines or encryption engines, or even just ARM cores inside of an offload engine on the server.
So here's a slam down term came up, EBOF. Anybody want to comment on that? And this is a lightning round, so we'll start with John first.
Yeah, an EBOF stands for an Ethernet box of flash, and the difference between an EBOF and a JBOF is down in the way that it's designed. A typical SAS box of flash would have a SAS switch inside of the enclosure that would then fan out to the drives. A JBOF for NVMe over Fabric today typically doesn't have an NVMe over Fabric switch. Instead, it has some intelligence that's a protocol converter from NVMe over Fabric to the NVMe. And an EBOF, on the other hand, goes back to having an Ethernet switch. And those little protocol converters are either in paddle cards on the drives, or there's even talk of Ethernet drives coming that are there. The interesting use case there is being able to leverage all of the bandwidth of those Ethernet switches that keep growing and growing as John pointed out in their performance and coming down in cost.
John, any further comment on EBOF?
I think that I'm going to argue that EBOF is most likely to be deployed for disaggregated storage because the EBOF is exactly as Walt defined it. And so it's usually fast, it is fast flash storage connected by Ethernet to the network. And it usually has limited amounts of storage intelligence or storage software on the EBOF, which means that it's ideal for a scenario where the rest of the storage software or most of the storage software is running on the servers, which is typically a disaggregated storage deployment. However, EBOF could also be deployed as a special type of disk shelf or as storage behind a centralized storage server. So EBOF could also be part of the centralized or SAN or NAS storage.
Okay, that was a nice jab, John. That was good. So we're gonna let Christine off that one because there's a question from the audience directly to Christine. So here it is.
Okay.
Why is HCI growing so quickly and seems so popular of late? It seems to be one of the fastest growing data storage use cases.
Yeah, well, I think it's because people are recognizing that hybrid cloud is the model that they really want to get to. And not everything in their data center can be moved to a public cloud for certain, preference reasons or regulatory or privacy concerns. And so people want their on-premise infrastructure to be as cloud-like as possible, more efficient, more performant, easier to manage, and hyperconverged is sort of the easy path for that.
All right. Well, thanks, Christine, for that. And I'm going to go back to John on this one. So put on your pontification hat. And this is another question from our astute audience. What is the current implementation mix ratio in the industry across the three options that we've talked about? What is the long-term projected mix ratio? So this is a good marketing question for you. Go.
So I can't give the specific answer. I would say, of course, most disaggregated storage is deployed in public cloud today. And some of it's moving into large private cloud or hybrid cloud. But most enterprise storage, including enterprise private cloud, most of that today is centralized or hyperconverged. So if we just look at enterprise, the vast majority goes to Walt and Christine. Vast majority of deployment today. And if we look at cloud, it's a mix. I would have to say, probably about 30, somewhere between 30 and 50% of that public cloud storage is disaggregated. But it's hard to say. A lot of public cloud storage could also be, centralized, or some of it could be hyperconverged, and some of it is still direct attach or local. So probably, if let's say public cloud storage is 40% of the storage market today, and enterprise is 60, and maybe 50 or 50% of public cloud storage disaggregated. That means disaggregated is like 20% of the total storage market. And then I'll let Walt and Christine fight out over who has which of the enterprise, since enterprise is, again, almost entirely centralized or hyperconverged and some local.
Yeah, I think I've seen that centralized. I mean, people are certainly still buying centralized, but it's a little bit more flat in terms of growth rate. But there's a very large install base of centralized, right? Hyperconverged has been growing very rapidly over the past few years, so it's been gaining on that. And certainly, as people try to move to more more modern deployment models. So there's where hyperconverged has been gaining share.
What do you think, Walt?
Yeah, I agree. I think that hyperconverged is growing in terms of the percent of capacity that's being delivered there. Just a note, it's sort of in the cloud. It's hard to know exactly how they do all their implementation, but certainly if you were to look at somebody like AWS, their elastic block storage is a network storage system. So is that central or is that disaggregated? Well, I don't know the details of the implementation, but it's certainly separated from the compute complex.
Excellent. So let me remind the audience to please continue to submit your questions. I'm blinded by all the lights going off on the phones, but please continue to bring them on. We can take it. So those are really good strategic marketing answers. As a strategic marketeer, I would say you've received the Noble Award for that. But now let's get into the technical under the hood. So this is the under the hood round. So where does the storage controller or storage intelligence live in each of your respective areas?
Well, in central storage, it's easy. It's in the controllers that are part of that central storage. I think as we talked about in composable disaggregated, well, that could be in the future some combination of stuff that lives in the server and stuff that lives in central storage. Or you could think of it as the software-defined storage that Christine talked about, moving into intelligence that's in a separate compute complex from the main server.
Okay. How about you, Christine?
Well, typically with hyperconverged, the controller is in a VM running on one or all of the servers. So it's typically distributed across the cluster the same as the data. So if a node goes down, then you've still got other nodes who can pick up and run the system.
All right. How about you, John? Where does the storage controller or storage intelligence live in your area?
Again, you could put it anywhere, but most of the time with disaggregated, it's actually similar to what Christine said about hyperconverged. It lives on the different servers, but the difference is that the storage tends to be physically separated out, in dedicated storage arrays or EBOFs or JBOFs, and then so most of the time the intelligence is on the servers, and that's because part of it is that the storage itself usually doesn't have a lot of smarts compared to centralized storage. It's relatively centralized storage is almost always smart. Disaggregated storage, the storage parts are usually, if not, well, maybe not dumb, but not as smart, not as capable as that centralized storage. And therefore, to get all the intelligence or the partitioning or some of the provisioning or maybe even some of the security features, you need to run that storage software on the servers that connect to it.
I would disagree a little bit with you, John. I think you're right about certain situations or certain solutions that are in the market, but I think there are others where there's still a fair amount of smarts in each of the servers in the disaggregated solution, depending on how high performance a computing need they may have, how many, even though you're not running compute workloads, right, you want to be able to do intelligent things with your storage to help manage it more efficiently. So I would say sometimes there's very little, as you said, but sometimes more.
Actually, you are right, Christine, you are right. And I would say that, for example, a lot of the flash storage startups that support disaggregated, they do have, as you said, a lot of intelligence and in the storage, each of the storage controllers or storage servers, and then maybe some of the larger scale public cloud implementations where they wrote their own storage software. I think maybe those are more likely to put the storage software on the application servers. And some of it could be in a SmartNIC or a DPU as well.
Could be. Mm-hmm.
Well, I'm going to give that roundhouse punch 3 points to Christine for that one. Here's an interesting question from someone you know. What is the most secure storage methodology across the three?
Well, one of the advantages of centralized storage is the intelligence is most commonly not running on the server. And so as a result, it's not, it's much harder for somebody to mess with that intelligence to to go in and access the data, for example. Whereas on the server, it's a little easier to imagine how to do that. So personally, I would say centralized storage is more secure.
I wonder why. All right. How about John? What do you think? What's your opinion there?
So most of the time, I hate to admit it, but Walt is correct. That, well, so actually, I won't comment directly on hyperconverged, but if we just look at centralized versus disaggregated, most of the time, centralized will be more secure because it has the security features or capabilities contained in the storage array. With disaggregated, those security features, some might be in the, part of it might be in the storage array, or part of it might be in the servers, or it may be in a deployment where they believe the data center is secure and not open to the public, and therefore they have less security or fewer security features or less security software running. But again, you can have disaggregated storage solutions with lots of security capabilities built in, but that would be a sort of specific to a particular vendor or implementation. But on average, Walt and centralized storage win on that one.
All right. Well, there's an award there for Good Samaritan back to Walt. So how about Christine? What do you think? Does HCI support security?
Yeah, I think that there's been actually a lot of advancements in security in the last couple of years, really. But I'd say most of the HCI solutions that are available are protecting your data at rest, for sure. And then the question is, what about protecting your data, while it's in compute or memory, while it's in motion across the network? And there it's really it varies quite a bit, and it's up to the user or the buyer to investigate what options are offered. There's a lot of ways that people can accelerate encryption, for example, either in software or in hardware, in order to make it much more feasible to encrypt everything without a big hit to your performance, as there might have been in the past. So, definitely read up on the latest technologies that are available, because there have been a lot of advancements in hyperconverged, and I think in the other storage methods as well over the last couple of years.
So we've talked about data and data movement, cloud to edge applications. Which storage approach across the three here makes the best sense?
I mean, we could give you the old "it depends," but really it's hyperconverged, right?
I think the answer is it depends.
I'll give you my version of it depends, in that if you're looking at enterprise edge deployment, branch office, remote office, many of the enterprise deployments for hybrid cloud, I think it's going to be hyperconverged. And then maybe for some bigger private cloud, it'll be centralized. And for really big private cloud or a public cloud, I think disaggregated. But again, disaggregated, usually the economies of scale or the economic benefits of disaggregated and many of the management benefits often don't kick in until you get to a pretty big deployment, which again could mean at least hundreds of servers, and possibly not just hundreds of servers in the data center, but you need hundreds of servers for a particular type of application or section of the data set or that department before it makes sense to do the disaggregated storage. So if someone's doing a deployment that's 10 servers, it's unlikely to, or 20 servers, it's very unlikely they'll do disaggregated storage for that.
Well, let me we're just going off the rails on these questions coming in. So, there was a San Francisco question that came in. Can these three storage methodologies work in harmony together? another one that came in from the audience, which is, can you imagine a realistic scenario where the different storage types are used as storage tiers? How much are they interoperable?
Interesting.
Yeah.
Well,
So,
I've certainly seen cases where people have a deployment of hyperconverged that they're using for their hotter data or their primary data. And then as that data ages, they move it out to a more backup and archive type system that's disaggregated. I've certainly seen a lot of cases of that.
mm-hmm. Walt, what do you think?
Yeah, I think you can use any of the models here. The notion of tiering is done even today between inside of what you think of as an enterprise storage array, but also across arrays or from storage systems to the cloud. And so that same kind of tiering can be used between your HCI systems and a central system for aggregating larger sets of data from branch offices, for example, or from stores into a central data center, or perhaps out to a disaggregated environment for archive or analytics use cases.
So it sounds like there's a place for both, or for the three, right? So it's not, for this sake of this debate, I hope it's one versus the other, but it sounds like that all three can exist in different forms, which is...
I think where it gets challenging, right, is if you want to be able to run analytics across data coming in from a lot of diverse sources, the more that you can put all that data into one storage system, regardless of type, right? The easier it's going to be to run those analytics workloads across these diverse sets of data. What you want to avoid, I think, as much as possible is silos of data, where you've got, stranded pieces of data that you can't pull into your analysis, and you're not benefiting from that data to really advance your business and give your customers a better experience. So the more that you can pull the data together and be able to run those kinds of analytics, I would say that's general guidance that would serve a lot of business as well.
So here's another question that came in. So Storage Performance Council benchmarks, SPC benchmarks, are still the gold standard, maybe, question mark. And so is that going to change given these new topologies that we're talking about here? How do you benchmark each one of your areas from a performance?
Well, that is a challenge, actually, because I'm involved in a lot of benchmarking efforts, and every vendor's kind of got their favorite benchmark, and so it makes it very difficult to compare across them. I think one of the things that's becoming most common is to benchmark a database, for example, on any of these types of systems, and measure your performance, because a lot of people intuitively understand database requirements and that it's a relatively demanding workload. And so if you can use a database benchmark, for example, across different systems, then you might be able to use that as one metric to compare.
Awesome. So, Walt, with the rapid adoption of computational storage, inline compression dedupe of 2-to-1 ratio, EDSSFF, and 0.5 to 1 petabyte capable 1U servers, SmartNIC, significant increases in processor performance, and 400 gigabyte networking, where do you think traditional centralized storage will compete in the future?
Well, I think it's gonna continue to compete in some of the spaces that it's been. One of the things we haven't really talked about is that all of the storage platforms are morphing. So, for example, if you look at centralized storage, there are centralized storage platforms on the market that can run applications. There are also HCI platforms on the market that can serve up storage to other hosts, like a centralized storage system can. So I think you're going to see some of the lines between those blur. But I think, that, hey, it absolutely, positively needs to be there, and I need it secure and highly available. I think that's going to stay as a place for centralized storage. And as Christine says, some of the places where, hey, I'm trying to develop a more cloud-like on-prem usage model where I don't need to think about separately managing storage, HCI can help to address those. To be fair, though, there is also a notion called CI, which takes central storage and marries it with servers and provides an HCI-like management of combined networking, storage, and compute that gives the customer the same kind of experience that HCI does in terms of simplifying.
You raised your shiny shield and took your sword and defended against that question that came at you from left field. So great job on that. So you're welcome. So John, this one's right in your wheelhouse. Disaggregation of how about disaggregation of other resources, networking, GPUs, memories? What do you see the trend there being? And is there a play for centralized to just tip our hat again to Walt, or is this pretty much disaggregated or bust?
Well, okay, so I'm not sure I understood the last part of the question, but let me talk about the other resources. So as I mentioned, you can disaggregate. When you disaggregate storage, you're sort of by definition disaggregating the compute, just because you're separating the storage and the compute. The difference is that normally the default scenario is the compute and the memory, and if you have GPUs, and the CPUs and GPUs go together in one server, in one tier, and the storage goes into a different tier. Now, you can disaggregate parts of the compute. You could create, for example, CPU-heavy servers or GPU-heavy servers or servers with FPGA acceleration cards or other specialized ASICs and separate those out. And then when you do this kind of disaggregation, you often have some, bring in some kind of composability and say, I'm going to compose or take whatever specific resources I need for each application or each job, bring them together, do the work, and then I can return those resources to their pools and use them for compose something else with them later. And then you can disaggregate the memory, but as I mentioned, that requires usually very fast, not very high bandwidth and low latency networks. Otherwise, the memory on the other side of the network, the disaggregated memory, is often seen as very slow relative to local memory. So you can do that, and you can disaggregate networking. So by its nature, every server and storage node or memory node has to have some networking in order to be disaggregated and still work as part of the system. But you can take the networking control plane and move it and disaggregate it and move it around to different areas. It could run in a VM. It could run in a hyperconverged, management layer. It could run in. You can move it to the switch, to the top of rack switches, or you could run it in software on the CPU, VM or container, or you could run it on a SmartNIC or a GPU. So disaggregating the memory control plane or networking control plane and networking intelligence maybe is something the next step or next easiest step after the storage. And then disaggregating the memory is technically easy to do, but making it happen with high performance is tricky. So that it's not clear to me if that's going to become popular or not.
But disaggregating GPUs is likely to be one of those trends that is going to take place as well.
Yes, because with that, you can often move the data that the GPU needs to process over to the GPU tier, process it there, and then just bring back the results. You don't have to have you don't always need this real-time data exchange between say the storage and the GPU or the CPU and the GPU to effectively do that. So yes, you're right. That gives you the option to disaggregate the GPUs.
I would say there's certainly a lot of interest in fully composable infrastructure, right? That's kind of the holy grail that I think people want to try and get to eventually. But the question is, how do you make that easy? How do you release those resources back so they can be used by other things when they're no longer needed for their initial purpose? I think there's still work happening on that, but certainly there's some early versions of that already available, and I think that's where people would like to get eventually.
All right, I'm going to jump in with a lightning round. This is a one-word answer, yes or no. So someone went up to the mountain, so maybe Monument Peak, and said that 90% of the world's data was created in the last 2 years. That's what they came down with.
Oh, yeah.
Can HCI, hyperconverged infrastructure, keep up with that pace? This is just a yes or no answer. So, John, your answer, sir.
No, it can't keep up with all the data.
Okay. Walt?
No.
No. Okay. And last but not least, Christine.
I would have to say no, not all the data as well. Yeah.
Wow.
With that volume,
answer.
yeah.
Okay, I'm going to switch us back to our slides here. And let's do there. Okay, so first of all, I'd like to thank our panelists. I think you followed the ground rules real well, but I don't think there was just one winner. I think there were a lot of winners, and the audience were the winners. So really good information that all three of you shared. I know I'm coming away as a better person from this great debate that you led for us. And so I wanted to offer up to the audience that there are more great storage debates that you can take a look at your own convenience through the SNIA.org website. You can see them listed here. All of our SNIA video, and also check out our SNIA video YouTube channel, and you can see the link there as well. And certainly we will take a look at the many questions that came in that didn't have a chance to get answered during this debate too. So we'll share those with the panelists. After this webcast, please rate this webcast and provide us with your feedback. It's really, really helpful. We spent a lot of time in preparing, and we want to continue to refine and make things better for you, the audience. The webcast and a copy of the slides will be available at the SNIA Educational Library at this website, and a Q&A from this webcast, including answers to questions we couldn't get to today, right, will be posted on our blog. And follow us on Twitter. And with that, I want to thank our panelists one more time, and thank you, audience, for participating in this debate. And I'm David McIntyre from Samsung. Everybody have a wonderful day.
Thanks much.
Thank you.